First of all, thank you very much for doing this. I know a lot of people have been interested in what you're doing lately. You've gotten a lot of people are excited about stearic acid and some of the other things I know you've been doing for a while. I heard Mike Eads talking about that a couple of years ago, and I don't know how long you've been looking into this stuff, but just give us a little background history on you. So for the people that aren't familiar with what you do,
Sure.
where you come from.
Yeah, so I have a molecular biology degree from Cornell. And so, I started my kind of career doing science in the lab. I worked at Memorial Sloan Kettering Cancer Center, and I worked at the Berkeley Drosophila Genome Project. So, I have a science background, but I didn't go very far down that career route. I actually wound up while in New York, went to the French Culinary Institute, and then ultimately moved back to rural upstate New York and bought a farm. And I've actually been raising pigs and running a butcher shop for the last 15 years. So really, I'm a farmer who happens to have a science background. I'm a pig farmer. And so that's kind of, so that's like what informs a lot of my thinking now. And I've seen since I was actually in the kind of cool position of being able to raise the animals out on pasture, and then also work with them in the butcher shop, and having the kind of culinary background, it really allowed me to see the differences that, if you feed animals one way, the meat and the fat comes out this way, and if you use that breed, it comes out that way. So, that sort of informs a lot of how I think and what I do. The fact that, I'm a rural farmer in upstate New York, sort of struggling with the economics and reality of running a farm and all that takes. But then the other kind of storyline that comes in is like you say, the stearic acid stuff and the hyperlipid stuff. And so, while running the farm and the butcher shop, I didn't always have time for sort of self-care, and because it was just around the clock workload. And, and so I realized, I stepped on the scale in, January of 2019, I guess. And, realized that I was like very overweight and that I had to do something about it. In the meantime, I had read, I had done keto and carnivore or not really carnivore, but I read the Dr. Atkins book in like 2002 or something. And so I have been doing low carb for I've been doing low carb on and off for a long time. I didn't get to, my 253 pounds, I think I was in January of 2019, by being very strict about my diet, in fairness, but that was sort of, where I was coming from that was kind of, where my mind was. And so I started to do keto again. And I found that as a 44-year-old, the weight didn't come off like it did when I was a 25-year-old when I tried it. And so I'd long been interested in this blog called Hyperlipid. And so, which is Peter, gonna butcher his last name, but Peter Dombrowski's blog. And he talks a lot about, mitochondrial events and the production of something called reactive oxygen species in the mitochondria, which is something that happens in response to eating saturated fat and eating stearic acid, and also palmitic acid, the other kind of long chain saturated fat. And about a lot of the dynamics that take place in the mitochondria of the fat cells and how that can affect your weight loss. And so the idea is that basically, if you eat a lot of long chain saturated fat, your fat cells become relatively, they stop responding to insulin as efficiently. And what that means is that one of the main things that insulin does is it stops a process called lipolysis. It stops your fat cells from releasing their energy to the rest of the body. So insulin stops the process essentially of your fat cells feeding the rest of your body. And so the idea is that by eating a lot of highly saturated fats, you can actually force your fat cells to continue releasing their stored energy to the rest of the body. And there was one mouse study in particular where the mice had become very lean, and I looked at what they were feeding the mice, and it was basically starch and stearic acid, and this forced the mice to be very lean. And I thought, well, that's interesting, because as a chef and as being someone who's interested in French cuisine and French culture, and I love food history and I love culinary history, and I have a lot of really old cookbooks, and I can look back and say, well, the French were very lean in, say, for instance, 1960 or 1970. This is pretty well documented. And at the same time, they're eating croissants, and they're eating baguettes with cheese and butter. And so when I looked at this mouse paper, I thought the diet that they're feeding this mice seems very similar to what, the French were eating historically that kept them lean. And it's ironic because, of course, what everyone says is never combine starch and fat together. But yet we have whole cultures suggesting that this is a healthy way to eat, and it's making these mice lean. And of course, that was what gave me the idea to do, sorry about that. I'm struggling a little bit with the audio visuals here. And that's what gave me the idea to do the croissant diet, which is admittedly, it's kind of cheeky and it's kind of funny, but it's based on a lot of historical knowledge about, different societies in Europe, America, and Asia, and Africa, where people were combining usually dairy fat with starch, and they stay metabolically healthy that way. And so I, as a, relatively metabolically unhealthy person, right, who grew up in America, in small town America, eating at McDonald's, eating Kraft salad dressing growing up, thought, could this actually work in me, a real live American, to try to go back to this, historical diet of what basically the French eat and stay lean on? Could it work on me? And so I tried it, and I lost weight like immediately. I lost like 10 pounds in like a week and a half or something. And I lost inches off my waist. And so, that was the sort of eureka moment when I thought, maybe I'm onto something here. And so I published that, and obviously that's gotten quite a bit of attention. And that kind of brings us up to now.
Yeah, so I mean, and I think that's kind of interesting stuff, and certainly a lot of people point to the French paradox, and there's a lot of things in the diet that people say red wine, and they smoke, and they eat a lot of obviously the French culinary stuff is lots of sauces, lots of butter, lots of cream, and a lot of people point to them as saying fat is not bad. So I mean, it's interesting, the croissant angle that I think is kind of neat. And I mean, certainly it tastes good.
Yeah.
And I think this is an interesting thing. I mean, I think in general, I mean, there's a real dearth of knowledge with regards to just fat in general. I mean, a lot of people think fat is just fat, and or saturated fat is just saturated fat. And as there's short chain, medium chain, long chain, and there's different, whether it's acetate, propionate, butyrate,
right,
acrylic, caproic, lauric, myristic, oleic, palmitic, stearic, all those have differential effects on the body. And, we just kind of ignore that, and we just kind of lump all saturated fat together. And, I think that's something that in different sources have different things, obviously.
Right.
A lot of
and so on my blog, I actually have a couple articles talking about, sort of the French diet. There's one called The French Diet in France. There's one called The French Diet in Upstate New York. And this is about historical diets. But I also have one called The Anti-French Diet. And what that one talks about is right now in the Middle East, there's a massive crisis of obesity and diabetes, worse even than in the US. And that diet is very much based on starch with vegetable oil. And so, the interesting thing about this theory is it actually explains some of the variation that you see around the world, whether, cultures are eating, starch with soybean oil versus starch with butter, as the French traditionally were, although the French have also moved to a much more sunflower oil based diet, and they're also becoming obese. And so, they're now consuming something like 400 to 500 calories of vegetable oil a day. And they're, like the rest of the world, are now becoming obese. So, when I look around at sort of world trends, it makes a lot of sense in that context as well, I guess. And so I also, on the blog, I have an article called, I think, The What's, Whys, and Wheres of Fat, which really, like you say, starts to break down all of these different types of fats and chain lengths and why they're found where they are. For instance, the long chain omega-3 fats are very liquid. And so, if you're a salmon and you have to swim in, 35-degree water or 32-degree water, and your body fat is mostly stearic acid, that's not going to work out well for you because, stearic acid's melting point is like 170 degrees. So a trout really can't, or a salmon really can't have a lot of saturated fat. It's not going to be liquid at the, they're not warm blooded, right? And so they would literally like freeze into a block if salmon fat was the same as beef fat. And so, and same with plant seeds, they have to grow when it's very cold. They have to germinate and grow. And so that's why you see a lot of the polyunsaturated fats in like corn seeds or corn oil, for instance. But in animals, like warm-blooded animals, we don't have the ability to produce polyunsaturated fats. And so we seem to prefer that our body is made of more saturated fats. And this makes a lot of sense. Saturated fats are stable. They don't oxidize. Well, it's possible to oxidize them, but they don't oxidize nearly as much as something like vegetable oils. So saturated fats are very stable, safe fats. So if you're going to choose to build an organism that's not going to have problems with peroxides and things like, 4-HODE, they call it. A lot of these breakdown products of vegetable oils can be very damaging, which is kind of a separate issue from the mitochondrial things that I talk about on my blog. I have a series called the ROS Theory of Obesity, and that really breaks down into the mitochondria and why when you are metabolizing saturated fat, it's creating these reactive oxygen species, which are free radicals. And that's a scary word that people don't like the sound of, but that basic process of free radical production in the mitochondria when you eat fat is conserved for over 1 billion years. So there's another article on my blog where I talk about C. elegans, which are these little nematodes, and they live in the soil, but scientists like to study them because they're a pretty simple multi-celled organism. And so, we learn a lot about biology based on studying these organisms. And so what you find in C. elegans is if you starve them of glucose, it looks to them like, okay, this is not a time of abundance, and so we shouldn't reproduce right now. And they'll actually live 3 days longer, which they only live for like 20 days or so. So 3 days for C. elegans is a pretty significant life extension. And so if you don't give them glucose, they will, they'll live a little bit longer, hoping to find more, a better, more rich spot to reproduce in. But if you starve them of glucose, and then give them an antioxidant, they won't live the 3 extra days because, and the way that works is what's actually happening is when you starve them of glucose, they start consuming their own body fat, and their own body fat creates these free radicals and called ROS, or reactive oxygen species. And the ROS production is the signal to the organism of what the mitochondria is doing. So I say in my blog a lot of times ROS is the signal, because the ROS, when the yeast or when the C. elegans switches to using its own body fat, it creates the ROS. The ROS turns on transcription factors, which changes what proteins and what genes are being produced. And that ultimately is how the organism knows that glucose isn't available. And so when you give them antioxidants, in addition to starving them of glucose, they no longer know that the mitochondria is being forced to burn the animal's own body fat. And therefore, the organism doesn't know that glucose is low, and therefore it goes ahead and reproduces anyways, despite the fact that there's not any glucose around. And so, you know, that switch, this ancient switch, so that the organism knows that it's burning fat, is actually literally broken when you eat soybean oil. And so my thinking is that that could well be, you know, a very fundamental issue informing a lot of our current, you know, issues with metabolic syndrome and diabetes and obesity. Like this is a really anciently conserved signal, this ROS signal produced in the mitochondria. And if you don't do that, the organism becomes dysregulated. And so that's, you know, that's the other. So yeah, I guess I feel like from a lot of different angles, you know, from the looking what happens in something like a C. elegans, looking at the traditional health profile of the French versus, say, someone today in Kuwait. You know, the French person ate butter and baguettes and was lean. The Kuwaiti eats, you know, whatever, rice with soybean oil and is obese. And so I think the theory, you know, and like I say, it's not all credit to Peter over at Hyperlipid. I mean, it's his theory. I'm just simply trying to put it into more real world terms and trying to kind of like, okay, well, this is really interesting, but what does it mean in the real world, you know? And that's sort of where my background in cuisine and cooking and historical knowledge and farming and seeing how what we feed the animals comes into play. Because the other way that many of us are getting a lot of this soybean oil is via the monogastric animals that we eat. Cattle, or ruminants, I should say, have a unique feature in that they will actually hydrogenate the fats that they consume and turn them into mostly saturated fats. But in a pig or a chicken, if you feed them soybean oil, which we routinely feed chickens soybean oil in this country as a supplement on top of their already corn and soy-based diets, then that soybean oil is what the animal is made of. And so, you know, my other thought is that pork and chicken fat is another kind of Trojan horse for the, you know, soybean oil. We obviously grow massive amounts of soybean oil in this country. I just drove through the Midwest, and what a lot of people probably don't understand is that the reason we grow so many soybeans is that out of all of the different plants, they have the best protein profile. They're high in especially lysine, which is often the amino acid that's really hard to get from plant-based sources. And so soybeans are grown to such an extent because they alone can allow us to grow things like chickens or pigs on an entirely vegetarian feed, which is to say a cheap feed, right? They're not doing it because they're like vegan activists or something. They're doing it because it's cheap. But the problem is that it's been known for a long time that soybeans, you can't feed whole soybeans to pigs because it makes the fat really soft and you can't slice it into bacon. It creates all these problems in meat processing. So historically, all of the oil is removed from the soybeans, and then you have the meal, which is the condensed protein. And that is what is crucial to the sort of CAFO concentrated livestock industry, is this soybean meal. But then that means that we have this sort of flood of soybean oil, right? And we have to do something about it. And so, you know, what we've done is we've just fed it to the humans. But we also feed some of it back to the chickens, and we feed some of it back to the pigs. And so now they're also like little tubs of soybean oil, unfortunately.
Let me, before we delve into that a little more, because One of the things a couple things. So one, as many people don't realize, in this country, in the United States, we currently get as much or more of our calories from soybean oil than we do from beef, which is, most people don't realize that, but it has become extremely ubiquitous. And not only is it it's in all the processed food. I think soybean oil is the oil of choice, the vegetable oil of choice in the United States currently, or the seed oil of choice. The thing about reactive oxygen species and then exogenous antioxidants, people don't realize that we need both. That the reactive oxygen species serve a purpose, and then the antioxidants, particularly endogenously derived ones, serve a purpose. And then when we disturb that balance, by dumping exogenous antioxidants in there, that may actually be a negative in some cases. And the other thing, you talk about the mitochondria, and I think this is, there's a concept of mitochondrial overload when it comes to the development of metabolic syndrome or insulin resistant. And we see these, these incomplete oxidation products and one of the things that gets pointed at often is palmitic acid as being, contributing to that. And then this ends up resulting in these things called ceramides, which are, again, being looked at as possibly some of the early pathophysiology of insulin resistance. So I think those things are interesting. I want to say, what are your thoughts on, because I've in Asia, pigs are the number one eating animal on the planet, as you probably are well aware.
Yes.
So when you look at Asia, and so we've got a long history of people in Asia that have been lean, that have been, relatively free of metabolic disease. They've been eating pigs forever. Why are these people not developing? They are now, they're starting to develop some of the things we're seeing now, but why were they able to avoid that? And I know they were eating grain-fed pigs for a long time. They've been feeding grains to animals for quite a long time. And so
right.
Why do we have that population that looks okay, and now we're saying that maybe it's a problem?
Yeah, so that's a really interesting question. And so I also happen to be a huge fan of what is colloquially known as the China Health Study. And I'm not talking about the paperback novel that T. Colin Campbell produced. I'm talking about the original 800-page hardcover manuscript that was studying people in '83. And so what you see in China is that pork is the most commonly eaten meat, to be sure. But again, pigs are what they eat. First off, people in China, peasants in China at least, don't eat a tremendous amount of pork. 100 grams a day would be sort of a high amount for them. And that's going up. But historically, they didn't eat a lot of meat. But also, the pork industry in China is very interesting because even to this day, they get something like 60% of their pork from farms that are producing less than 50 pigs a year. So these are very small farms, and China, ironically, historically didn't produce a lot of soybeans, because these are homestead farms. And the problem with soybeans is that raw soybeans, the animals can't make use of them. You have to actually cook the proteins are inaccessible. So you have to do something like process the soybeans before you feed them to the pigs. And so soybeans are not a good homestead food for pigs. So what would they feed them? Well, a lot of them finish pigs on sweet potatoes. Sweet potatoes have almost no fat. Sweet potatoes make a beautiful, firm pork fat that is going to be very, very low in linoleic acid. The other thing about these pigs is that they would be historical old-fashioned breeds. So another thing that happened in the 1990s is when we were breeding for, quote, the other white meat, is there was this huge genetic shift in the types of pigs that we're using. And so the pigs that we use now are actually incapable of doing, well, I shouldn't say they're incapable, but they're very inefficient at doing de novo lipogenesis, which is the process of turning starch into fat. And so traditionally that was really the whole job of a pig, was you feed it, you grow sweet potatoes and you feed the starch to the pigs, and they're converting it into fat so that you can have fat for your diet, right? Well, these modern pigs can't do that. And so, so these Chinese pigs, you know, an old fashioned fatty breed of Chinese pig being finished on sweet potatoes or on rice. Rice is also very low in oil compared to something like corn. You know, they would have had beautiful, firm fat. They would have made their own de novo lipogenesis, and pigs, like humans, can only produce saturated and monounsaturated fats. And so, so the traditional pork of China would be fantastic quality. But that's not, you know, so they were eating a very different kind of pork than what we get commercially. Although China is also shifting, much American pork is now exported to China, so they're changing the type of pork that they're eating as well.
Yeah, my understanding is, I guess this goes back to probably prior to World War II, perhaps there was, I guess, a more prevalent a lard pig, and then there's a bacon pig, and we kind of shifted away from the lard pigs to I guess because we no longer started using lard in favor of all these hydrogenated seed oils. And so, I mean, as a pig farmer right now, when I read, you know, how to feed a pig, how to fatten a pig back in the day, it was like skim milk, molasses, and then some sort of other grain product, and that's how they used to do it. Is that the analogous thing? It's just a different breed of pigs now?
Yes, I mean it all plays in. So right, that was a traditional homestead diet, and if you look at like classic European pigs, it was known back in the day that the best pork came from places like Denmark and Canada, and the reason for that is that corn doesn't grow very well in the far north, and so they had to use barley. And like you say, the traditional protein supplement would have been skim milk. So that goes back to your classic homestead. You know, the center of the homestead is the dairy cow, and everything else on the homestead is sort of dependent on the dairy cow, right? And so you keep pigs and you grow barley or you grow corn, and then you feed the pigs the corn, and then after you milk the cow, you collect the cream, which is the whole reason that people have cows in the first place, is for the cream. And then the skim milk goes to the pigs, and that's their source of protein. And that works very well on a very small scale homestead level, right? And but also, yes, those pigs also would have been being raised for their lard. They would have been old school lard pigs. I raised a lot of a breed called mulefoot pig, which I think of as the American Mangalitsa. Mangalitsa is an Austrian pig that's got a lot of press in the New York Times, etc. But a mulefoot is an American homestead pig, and they are very fatty. I raised a batch that were like 50-50 mulefoot pigs one time, and like I was trying to get their fat to firm up, and so I fed them this white wheat, and they were getting that in addition to pasture, and they found the white wheat incredibly palatable, and they got very fat indeed. the butcher shop I was using was not very happy with them, but it all plays a role. And so the modern pig that you buy in a grocery store today is almost nothing like the classic homestead pig that would have been finished on barley and skim milk. They're entirely different creatures. And so, in the modern pigs today, the thing about them not being able to do de novo lipogenesis is they're literally forced to use corn oil as their source of, that's the only fat they have access to because they can't make their own. And so, yeah, a pig is such a malleable animal. And this is why, pigs and humans have had such a close relationship for so long, because pigs are very adaptable creatures. If you want them to be long and lean and made of soybean oil, you can do that. Or if you want them to be, short and fat and produce an incredible amount of nice firm lard, you can do that too with a pig. They're quite amazing in that way, and they're fun to be around as well.
There's an interesting study that a guy named Michael Richards out of the Max Planck University did. I just thought it was an interesting study looking at isotope data in the Pacific Islands. And, they were looking at what humans were consuming. And what they found out is I don't know if you know much about the isotope data, but these stable isotopes can kind of inform us based on the carbon and nitrogen ratios what creatures eat, and you can look at their
Sure.
but what they saw was that these Pacific Island skeletal remains looked like the humans were eating, even though we were on islands, the humans weren't eating much seafood, they were eating pigs, but it turns out they were feeding the pigs fish, as I get probably as a protein and maybe fat supplement, which I thought was very interesting that they valued the pig so much over the seafood. That's just an interesting observation. But let me ask you about, well, one of the things, if I look up grass-fed beef and I look at the fat profile, there is still some polyunsaturated fatty acid in grass-fed beef, so there's still a small amount. And so I know you said there's none, but I think there at least is some. Regardless, I mean,
every food
has everything.
Literally every food is a combination of saturated, monounsaturated, and polyunsaturated fat. So yes, even grass-fed beef has some linoleic acid, and at the same time, even soybean oil has some stearic acid. It's about ratios. And so, I talk a lot. I have lots of charts of ratios and stuff. If you Google like the croissant diet, you'll see them all.
Does not absolute amounts also play a significant role in there? I mean, because there are absolute requirements for, things like the long chain polyunsaturated fatty acids. While they're not incredibly high. And so I tend to, in addition to ratios, I think, absolute amounts have a big role in that. It's kind of like the poison is made by the dose. Let's delve into stearic acid a little more, because you've got this product, I guess it's fire in a bottle. Like when I get fat renderings or beef renderings or beef fat trimmings from the butcher, and sometimes I'll cook them up, some of it's really hard. And my assumption, based on what you're saying, is that's going to be where a lot of the stearic acid is found, is because of the consistency. Is that a correct assumption?
Yeah, absolutely. And so, what I've found is that I think that the single highest, there was a good paper about this time back, and I'm unfortunately spacing on the guy's name. He's very well known, but he looked at all of the different ruminant fats and which ones were the most saturated. And it turns out that the kidney fat, especially the abdominal fat of wild ruminants, is highly saturated. It's probably something like 35% stearic acid and another 35% palmitic acid. So these are the two long chain saturated fats. And it kind of makes sense. I mean, when you kill and butcher an animal, the easiest, most accessible source of concentrated calories is that abdominal fat. I mean, you slit open the stomach and it's all right there. So it seems logical that those ruminant fats would have been prized by hunters and probably one of the first things consumed or stored. And, and so that, yes, but there's a very big difference between how saturated the meat from, say, the ribeye. Like ribeye fat is much less saturated than is beef suet or beef kidney fat. And so, when I'm talking about something like the croissant diet, I'm thinking that as a metabolically unhealthy person trying to get better, I know that my body fat is already full of these polyunsaturated fats because I live in America and I eat at restaurants, and restaurants cook everything. And if you order eggs at a restaurant, they're of course coated in soybean oil. And so even if you're trying to sort of do the right thing in America, it's hard. And like you say, they're in everything. You go to a party, you eat some tortilla chips, and it's all soybean oil, right? And so I'm thinking that as a metabolically unhealthy person, my body fat stores are probably full of this polyunsaturated fat. And I know that I'm trying to get to this very specific idea that I'm trying to force my fat cells themselves to stay in a mode where they're going to be releasing energy for the rest of the body, which is to say I want them to be mildly physiologically insulin resistant. And that's a reversible short-term insulin resistance that happens after a meal. And so I'm trying to force that. And I know that my fat cells are going to be burning some combination of dietary fat and stored fat. And so they're going to be burning this kind of blend. And so when I started the croissant diet, my idea was I'm going to eat lots of fat, and it's going to be highly saturated because I'm trying to sort of like overwhelm the pre-existing fats that are already there and part of the blend. So I think it's logical to say that something like the fat from like ribeye fat or you know, lard from a barley finished pigs, those fats are probably perfectly good fats for humans who are metabolically healthy. But in my case, if I'm actually trying to use the fat for weight loss purposes, my thought was I'm going to use the most saturated fats, stearic acid rich fats that I can get. And to that end, in my latest dietary trial, which has been quite successful, I started making something called Fat Bomb Fries. And so this is where I bought pastured local beef suet, and I rendered it down. And there's an article in my blog about how you can do this too. And I'm making these French fries, and I fry them. I have 2 vats of this suet. One is hot for frying, and one is relatively cool. And I fry the fries once, and then I put them immediately into the cool batch of suet. And what happens is as they cool, they like wick up more suet. It's like a sponge. So I've actually figured out a way to actually double the fat content of French fries. And so, and then I put them back in the hot oil again, and that crisps them up before I eat them. So by eating fries this way, I'm able to consume a huge amount of beef suet, which I don't like to eat on its own. So the sort of what I've been doing, which is of course counterintuitive to probably most in the carnivore or keto community, is I've been using these starches as a vehicle to consume as much of the stearic acid and highly saturated fat as possible. There are other ways to do it, and I actually am writing. I'm working. Well, when I get some time, I'm working on a series of articles about ways to incorporate more stearic acid in a carnivore context. I've got like 3 or 4 different recipes I'm going to get out there in the next couple of weeks because I've had tons of questions about it. And I do have, like I say, I have a chef background, and I've got some pretty cool ideas about that. So coming soon, I guess.
Yeah, I was going to ask you because, I mean, you know, obviously you're saying that, you know, it's the fat that's doing it, and saying particularly the quality and the type of the fat. And so I was going to ask you why the starch, what's the utility of the starch? And it's just basically purely a flavor preference, I would assume. I mean, I guess I could deep fry some ribeyes in beef suet or something, or some stearic acid.
Yeah, I mean,
beef suet.
Right, but the problem is that meat isn't very absorbent of fat. And so it's like
I could inject
you end up
I could inject it in my brisket and then smoke it. I mean, you know.
Well, I'll tell you this. So I'm working on a recipe. It'll be on my blog, but I'll give you the short version. So one thing I noticed in the butcher shop, we were making a lot of we were doing a lot of bone broths. And we had this big kind of 60-gallon cauldron that would simmer overnight, right? And sometimes when we did pork, in the morning, the broth would be the thing about pork is it would be skin on, and we'd have like trotters and feet and heads and all these very a lot of skin, and those things all make a ton of gelatin when you cook them. And so the pork broth would come out this real rich gelatiny. But I noticed that if it cooked down too much and that gelatin concentrated too much, what would happen is in the morning the broth would be this like milky white color, because the gelatin would actually emulsify the fat that was in there. And I realized that if you take a bone broth and you add a highly saturated fat, I've been doing it with like a stick of butter and then like 25 grams of supplemental stearic acid, and you take like a cup or 2 of the broth, and then you add a bunch of extra gelatin to it, and then you add your fat and you boil it hard, and it makes like this beautiful kind of white creamy broth that you can use. You can dip your steak in it, or you can eat it more like a stew, but it's like a great way to actually palatably consume very long chain saturated fats, which which once they get up to the level of saturation that I'm talking about, things like beef suet, things like I make this stearic acid enhanced butter, but they have, you know, kind of a waxy mouthfeel. I don't know if you've ever eaten straight beef suet, but it's, you know, it's an experience. And so I'm playing with ways of making it more palatable.
Yeah, I mean, there's many people here that just eat a lot of suet and they eat it directly and they fry it up and stuff like that and seem to do okay with that. You know, cocoa butter, as you know, is obviously got the most stearic acid of anything. Do you experiment with that, or do you find that to be helpful?
So I personally have not used any cocoa butter. I've actually only eaten it like once. It's not bad. But having said that, I've had, this has got quite a bit of attention because of who she is, but a woman named Emmy contacted me and said, hey, you know, thanks for the information on your blog. Like, I've been doing a keto and carnivore diet for literally 6 years. And she had failed to lose any weight. You know, I think she was postmenopausal and she'd gained some weight, and nothing she was doing could help take the weight off. And so she found my blog, and she actually cut out what I think was a lot of pork and chicken fat that she was eating, and she replaced it with, she was making like a blend of butter and cocoa butter. And she was eating that with all of her meals. And, you know, that made the difference for her. When she switched to that, she started to lose weight, and then a little tiny bits at a time at first, but she was encouraged because nothing, like, she literally hadn't been able to lose any weight at all. And she did pure carnivore for like 2 years, but, you know, carnivore with pork and chicken. And so she cut that all out, and then she started eating this butter and cocoa butter with every meal. And after a few months, her weight loss actually accelerated, which, if you believe the kinds of things I'm talking about, could be because she had burned through her body stores of the polyunsaturated fats. Obviously, that's pure conjecture, but it's logical. And so, you know, she was able to get down to her target body weight, and actually has now dropped well below her target body weight, just by switching the types of fats she was eating. And so, you know, that to me, obviously, she's one person, but it's another data point suggesting that the quality of fats that you're eating can make a pretty big difference.
Yeah, one thing I've seen, you know, I know there are human studies actually looking at human biopsy studies looking at fat contents of humans, and we do see a significant difference in the composition of human fat compared to what it was 50 years ago. I mean, there's actually comparative data where you can say, and we have this greater amount of these, I guess, you know, omega-6 fats, seed oil derived fats that take up residence in our tissues. And there's some thought, I mean, I guess it's speculative how long they stay there, but some studies suggest they take up residence and they stay there for years, and it takes a while to sort of cycle those out of the body. I don't know if you've got any data or
yeah, and I have, so there's another, right, these polyunsaturated fats are interesting because, you know, and I'll take it back to pigs again, because that's what I know, obviously, but like, sometimes I say there's no other food that you can give an animal that sort of like bioaccumulates, right? Because it's not like if I feed a pig starch, when I eat the pig, I'm not eating starch. If I feed a pig straight stearic acid, it's going to convert a lot of it to oleic acid, because pigs can convert saturated fats to monounsaturated fats. So just, you know, but if I feed the pigs polyunsaturated fats, they're going to store it as polyunsaturated fat. And so it can kind of, you know, it kind of bioaccumulates up the food chain. If you store that, you know, you are what you eat, and polyunsaturated fats are the one kind of food that you know, even if I give you protein, you're going to break it down into individual amino acids and build your own proteins. Like, because you eat wheat, you're not made out of gluten, right? So every other thing that you eat or feed someone, it gets broken down and reused in different ways, except for fat, which is you know, an interesting fact. And then there's another paper on my blog that I talk about. There's a gene called SCD1. This is a really interesting gene. It's the protein that converts saturated fats to monounsaturated fats. So so it turns out that if you take a mouse and you don't give it the ability to make monounsaturated fats, those mice are protected against diabetes and obesity for their whole life. The fact that their body fat becomes highly saturated actually prevents obesity and diabetes in mice forever. So I think that's another interesting data point. And obese people, there's another study I have on my website. Obese people tend to make a lot more of this SCD1 gene. And so in addition to their body fat being higher in polyunsaturated fat than lean people, it's also higher in monounsaturated fats and lower in saturated fats than lean people. And this SCD1 gene is upregulated by insulin. So you have this sort of positive feedback loop where people who are creating too much insulin are now storing their body fat in a more unsaturated form, which is then in turn continuing to drive the progression of diabetes. And so there's a lot of different ways that this you know, saturated and versus unsaturated thing plays out. And so if you really think that a key is the ratio of saturated to unsaturated fats, then, you know, obviously you just see it in play in a lot of different ways. You know, and the SCD1 story is really interesting. I'm going to have another article on that coming up because I think that's a really interesting story, and I've only sort of hinted at it. I mean, I talk about it in the Croissant Diet article, but and also I just saw in the comments someone wants me to talk about the banana milkshake study. So this is another study I talk about on my site. This has gotten a lot of people are interested in this. They fed volunteers basically a vegan diet for, I think it was just like 48 hours. It was a low-fat vegan diet. And what happens on that diet is the mitochondria basically, they dissociate from each other. They're just like these little individual mitochondria. And then they gave people basically a banana smoothie that had something like 24 or 26 grams of stearic acid in it. And they drink this smoothie, and then within like 4 hours or 6 hours of time, they showed on the under the microscope that the mitochondria all actually fuse together and make these like networks of mitochondria when they're metabolizing stearic acid. And so I think that article on my blog is called like, "This is what fat burning mode looks like," or something like that. But what's interesting that the mitochondria are making these huge structural conformational changes just from, you know, just from drinking a bunch of stearic acid. And they go in that study, they talk about how that it really is suggestive that those mitochondria are now preferring to live on fat rather than, you know, other things. And it's not like it was a pure fat meal either. It was a banana milkshake. So they were eating a lot of starch and sugar in addition to just the stearic acid. So that's been another thing that's gotten people talking about it.
Yeah, let me ask you one thing about the pigs, because I think how long does it take a modern pig done, you know, the sort of industrial style? It takes about what? How many months to get those things ready for slaughter? Those
pigs get to market weight of around 300 pounds in 5 months, or even a little under 5 months, which is amazing to me. The pigs that I raise, they're old-fashioned breeds, and they do grow slower. I mean, one of the reasons that the industry likes to feed them vegetable oil is it makes them grow faster because they have this source of fat that they can just pack away, right? And so the pigs I feed, they're on a very low-fat diet, and so they take, you know, they might take more like 7 months to get to market weight, and so that's and so, you know, it's a whole different animal. The old-fashioned, I'm using a Berkshire hog, which is an old British breed, which has great marbling. One thing this is an underrated thing that is a meat quality thing, is the final pH of the meat. So after an animal is killed, the muscle glycogen converts to lactic acid, and the less glycogen that the pigs have basically means that there's not as much lactic acid produced. So the final pH of the meat ends up being high, which is to say closer to a neutral pH. And when you're eating meat, a lot of the sensation of like juiciness and is actually attributable to the final pH of the meat. And so that's a great thing about Berkshires. They have great meat quality and great meat color, but a lot of that is due to the final pH of the meat. So these pigs, I'm very excited. They're going to be done in shipping the end of probably in November. So that's getting really excited. I'll say this is my new meat company is Firebrand Meats. That's where these pigs are being raised. It's actually, and I'm selling this kind of subscription model because I can't, because I don't have all the money to raise these batches of pigs up front. So I'm asking people to kind of sign up for a CSA share, and that helps me to afford to actually raise the pigs and get the thing off the ground. And people have been excited about it, so that's fun. But I'd like to, I kind of mentioned this before the show. I would love to talk for a second. This is like yes, at Firebrand Meats, I am creating low PUFA pork. Like that's the first thing out of the gate. But long term, I'd like to use it as a platform to raise the issue. One thing as meat eaters that we need to take, I think, very seriously is simply the lack of efficient meat processing in the U.S. So what's happened is that the meat industry is consolidated to where like 4 meat packers control, 85% of slaughter, right? And all of that pork, especially the monogastric, especially the pork and chicken, that stuff is all going to be, the other white meat, lean pigs, finished on corn and soybeans. It's all going to be, 15% polyunsaturated fats, probably more. That's more that. Modern pork has as much polyunsaturated fat as or as much linoleic acid as canola oil. Chickens have more polyunsaturated fat than canola oil. So that's kind of the levels that we're talking about. And so, okay, fine. I want to make this better product, and I want to do it efficiently, and I want to make it affordably. Well, now I've got a problem because the only slaughterhouses left that are not these huge industrial monoliths are these very small mom and pop butcher shops. And the problem is, if I'm like, if I know that as a business model, okay, I need to be doing a group of 50 pigs, I can't just call up the mom and pop butcher shop and say, hey, can I bring my 50 pigs in? The answer is going to be no. They don't have the space. They can't do it. And so there are no medium scale slaughterhouses in the US that you can kind of like scale up an operation and get to that next level of efficiency and get to that next level of cost effectiveness. So it's like you want to make a great product, but you're stuck. I've lucked into, having a few that I can work with, but it's a real issue. And the other thing is the cost. So if you work with these small slaughterhouses, you end up spending more on meat slaughter and meat processing costs than it takes you to raise the animal. So if we compare that to the industrial system, I don't like the industrial system, but there are things I'm impressed with it about. Like, it's incredibly efficient. And think about this for a second. To get an animal slaughtered and cut up, at least into primals, at an industrial place like this, basically costs $0, because what they do is they're shipping the spleens and the trotters and the blood and the bones. They're shipping it to China, or they're shipping it to Mexico, and they are selling literally every part of this animal is getting sold. And the slaughterhouses and meat processing facilities are so efficient that they can run the entire plant just by selling the byproducts that Americans don't eat. And so in my case, it's like, okay, it cost me, $350 to get this animal slaughtered and cut up and packaged. And if I were Smithfield, it would cost me literally zero. And so that's when you see these, like, you know, the economies of scale really start to play out as a small farmer. And that's why, you know, when you go to the farmer's market and, you know, pork is $15, it's because due to lack of slaughter, people can't scale up their operation, and the slaughter and processing is so expensive that you can't be price competitive. And so, you know, I think this is a real national crisis, to be honest with you. Like, you know, it's really hard. And so, you know, I can envision a future where there's like this network of kind of, you know, medium-sized, like slaughterhouses that can maybe do 500 pigs in a day, and a network of them along the country. But the reality is, to build a facility like that, you know, you're probably talking $30 to $50 million. And there's not a lot of investors out there wanting to drop $50 million on a kind of not sexy, not very quick payback investment, such as a pork slaughterhouse. And so, you know, I'm not coming here with solutions. I'm coming here to say, this is a big problem, and people need to be talking about it, and people need to take it seriously, because, you know, if we want better quality pork, and if we want it to be affordable, and if we want it to be available, like, something has to change, because I don't know, you know, it's not, yeah, it's just a real problem right now. So, you know, if anyone wants to write me a check for 50 million, I'd be happy to have this slaughterhouse built, but so far no one is stepping up to the plate on that.
Yeah, I mean, and I've touched on this issue many, many times with other guests, particularly on the beef side, you know, because we've got, you know, JBS, Tyson, Cargill, and National Beef, which now have been bought by Marfrig. And of course, on the pork side, it's what Smithfield, that China owns. And this is a huge issue. And, you know, there's a little bit of legislation being proposed out there. You know, the coronavirus exposed some of this stuff. There's a guy named Mike Calicrate, who I don't know if you know, he's from the beef side. He's done some stuff with direct-to-farm marketing that has kind of helped to do that on the beef side. So he's created his own sort of, you know, workaround for the exact same issue you're talking about. So there are some people doing it, but ultimately, I mean, I think it's going to be market driven, and I think it has to be the consumer that drives this to make this, you know, create this need for this stuff. And, you know, you are right. It's tough. You're up against corporations that are, you know, multi-hundred-billion-dollar companies that have endless resources to throw at it and make your life harder by tying up the slaughterhouses and, you know, kind of, you know, I mean, you're really going up against a big thing. And I think it's going to take, you know, literally millions and millions of people saying, hey, we want it done a different way. And I you know, just from, you know, I mean, we have a lot of people that do regenerative type agriculture, you know, which, you know, aside from the quality of the meat, it also has environmental impacts, which I think a lot of people are at least interested in. I think there may be just as much, if not more, interest in the environmental side than there is on the meat quality side, for good or bad. So that may be another angle to go at it with and say, look, I'm not, you know, I'm not degrading the soil by using all these monocrop produced inputs, you know, when you feed your pigs and stuff. So I mean, it's you know, you're highlighting an issue that we are well aware of in this community. And so, you know, like I said, one of the things is we grow as a community here and get stronger and get a bigger voice. That's certainly one of the issues that we definitely will be pushing after, you know, quality of the beef. Because you know, I don't know if the meat industry is going away anytime soon, but I mean, certainly there's attempts by people just to try to get rid of it completely and get us all in this, you know, soybean produced fake meat slop and or genetically grown stuff, which is going to be just as problematic in my view. So yeah, my hat's off to you. I mean, this is a tough problem. It really, really is. And I don't know if anybody's going to hand you a $50 million check anytime soon. I mean, there might be some people that you know, have an interest in something along those lines. You know, Silicon Valley's got a lot of money. They do a lot of investing in there. And so that might be something to, you know, there might be, if you can get a collaboration of, you know, 100 pork producers. I don't know if you're a member of Do they?
Well, I'm not, but I know some guys, and I think we might be. We've talked about it a bit, but it's sort of a bigger project, and so it probably will, like you say, it'll have to be driven by the community. It may have to be some kind of, we may have to get 10 different farms together, but I would, I'm hoping to sort of lead that charge over at Firebrand Meats. So, that's kind of my mission statement in the long term, is to help with some of these solutions. And, like I say, I'm very agnostic to how we solve the problem, but yeah, I just want to get out in front and start talking about it. And maybe somebody out here will hear this podcast, and you can get a hold of me on direct message me on Twitter if you've got any ways to solve this. I'm fire_bottle on Twitter. That's a good way to get a hold of me, and I respond usually pretty quickly to that kind of stuff. So yeah, if anybody's got any ideas on this, hit me up.
Yeah, I think, like I said, I think some of the guys from the beef side have similar issues. So you might want to look at a guy like Mike Calicrate. We interviewed him. You can look through our podcast and you'll probably find out how to get a hold of him to talk. Talk to me about the fire in a bottle stuff. This is stearic acid infused butter, if I'm not mistaken. Can you just talk about the evolution of that quickly and what it does or does not?
Right. Absolutely. And so like I say, the initial like spark of like aha moment was looking at this mouse study and what they fed the mice. And so they were feeding the mice starch with stearic acid. And so I was like, that's kind of interesting. Can I get stearic acid? And it turns out it is available. So I bought some online, and so I was like, all right, what do I do with it? I've got this now. What do I do with it? But I got it, and the melting point is like 170 degrees. So it's like candle wax. I was like, well, I can't just eat this. So I figured, well, if I melt it into butter, well, it'll end up somewhere in the middle, right? And so that's what I did. I kind of just added it little by little to the butter until it was like, if you add too much of it, it just turns to wax in your mouth, and you're like, well, that's probably too much. So I just computed. And so, the butter oil ends up being about 30% stearic acid, which is the same as like cocoa butter. But, it has what I consider to be a lot of the health benefits of butter, which is to say things like vitamin K2 and things like butyrate, I think are beneficial. And so, to me, I just think butter is a really high quality fat due to the vitamin content, and the flavor is great, right? And so I was just sort of like taking obviously a classic thing, butter, that we all know, and thinking like, is there a way to supercharge it? And so right. And I started eating it, and that was at the beginning of the croissant diet experiment. That was when, I was like, wow, that I really did lose 10 pounds in the first, 2 weeks or something like that. And so, while eating literally just croissants. And so, that was cool. And, I think that, that's just kind of where, that's kind of where that whole concept came. And so I do sell it. I'm actually currently sold out, but we've got another batch coming out around October 20th. But I am just selling the 90% pure food grade stearic acid to people can make their own at home pretty easily.
Yeah, I just want to, I guess, do you find that there's a satiety benefit of stearic acid over everything? Do you think there's a caloric, because a lot of people say, well, maybe it's the people that always say this is calories in, calories out, maybe it produces additional satiety, you just don't eat as much. Is that going on as well? Or do you think the stearic acid?
Absolutely. So I feel a huge satiety benefit from it. I mean, and I've always been a person who struggles with satiety. It's like, I would just, I eat a meal and at some point I just stop eating because my stomach hurts. And so with the stearic acid product, I mean, the satiation hits me hard. I mean, I just literally can't take another bite, and I'll set down the plate half finished. And that's the first time I've ever had that response. And I think that's also, but interestingly, there's also a mechanism we perhaps know for that, which is in the hypothalamus, is also monitoring for reactive oxygen species production. And your dietary fat is targeted to a couple of places. It gets offloaded into your fat cells, and it gets offloaded into your hypothalamus. And so when you eat a meal with a lot of stearic acid, the hypothalamus starts, you know, burning some of that. That creates reactive oxygen species. And it seems like that ROS production in the hypothalamus is perhaps essential to satiation. It might be essential, but not sufficient, or it might be one part of many parts that are causing satiation. But I experienced tremendous satiation from it.
Yeah, one of the things, I think leptin also has a role on the hypothalamus. And one of the thoughts with leptin resistance is there may be an alteration in the blood-brain barrier towards leptin or something along those lines that mitigates our ability to sense satiety from leptin when we become leptin resistant. So that's very interesting. You know, I guess ultimately in what I always, you know, at some point, you know, and I always, because there's, you know, there's guys that make, Ted Slanker Beef makes this omega-3 enriched beef, you know, and you know, we've got these claims about this meat being superior. And then I always say, well, we'd love to get some human data and maybe actually do a side-by-side trial. So it'd be fun to say, let's take 20 people and feed them standard pigs, and let's take 20 people and feed them Firebrand pigs and run it for 3 months and measure some sort of outcome, whether it's weight loss or, you know, and, you know, ideally, you know, I think when we do dietary trials, I mean, I think a carnivore diet is outstanding because you eliminate all these other variables and you have to calorie control it, because I mean, it's great to sort of say these things. And to me, it's still speculative. I mean, it makes sense from maybe a common sense standpoint, but I always say where the rubber meets the road, show me the results. And, you know, I mean, if people do it and they notice a great result, that's great. But, you know, at some point, like, I'd love to see people do these studies on grass finished versus grain finished beef. And because we hear a lot of stuff, people talking about this, and the producers are always passionate about it. And I'm like, well, let's, you know, fun to study. I mean, you know, you can probably do one for 50K. I mean, something like that. So it's not that undoable. You know, I mean, you know, in the scheme of things, I mean, we're raising money for a big carnivore study, which probably we're going to be quite a bit more than that, what we're going to spend. But at the same time, these smaller studies would be, I think, worth doing at some point. So you can say, hey, look, we've got diabetics whose hemoglobin A1C improved more, they lost more weight, their blood pressure was better, their, you know, inflammatory markers got better, whatever you want to. You can't measure long-term heart disease or something. That's not doable in any kind of study, in my view. But so that would be, I'd love to see someone do that, those types of studies, because it's not that I discount any claims you're making, but I'd like to see those studies done so you could, because I always tend to say, well, let's see what the actual results are in people, and hopefully someone will do it. So
I'd love to see it.
Yeah, sure. That would be great, because I think, you know, I fully support and agree, you know, raising these animals in a better quality way than we're doing now is intuitively it makes sense. Environmentally, it certainly makes sense. Health-wise, it probably makes sense, but it'd be nice to be able to back those claims up with a little bit more rigorous science, quite honestly.
Yeah, absolutely. No, I totally agree. But I also think that, you know, I mean, even now, I think there are a lot of multiple sort of points of evidence that this is probably good. But like you say, yes, having a definitive human dietary trial absolutely would be outstanding. But, you know, between, again, we've kind of hit on a bunch of them, but I'll summarize the lines of evidence that I think.
Hey, Brett, I'm just saying, but to that point, you know, like when you're saying, hey, I want to get a big network going, if you showed a human trial, that might lead to somebody funding. You know, you could say, hey,
oh, absolutely.
These people of course. So that may be a way to drive some funding into that Packer situation, perhaps. But
yeah, no, absolutely. No, I think you're totally right. And yeah, if we could we have to start working on building the network effect, I guess, which I totally agree with. But yeah, anyways, I'll just quick now that I'm thinking about it. So the basic lines of evidence, and these are all kind of on my blog, are the idea that, you know, one is looking at a society like the French versus the Middle East, where one is eating more saturated fats and stays leaner, despite the fact that the macros are very similar. Another line of evidence is mice studies, mice dietary feeding trials. Those are very clearly reproducible. Another one is this the SCD1 gene, which is a lot more prevalent in obese people, and which also the lack of it prevents obesity in mice. So that's another, powerful piece of it. And so, I think there really are, between the epidemiology and the studies that we have in mice, and the things around SCD1, to me, it's a pretty compelling puzzle. But I 100% agree with you. I'd love to have someone do a dietary trial of it. That'd be amazing.
Yeah, I mean, but and when I see epidemiology in mice studies, I would say that's the same evidence they use to say red meat causes colorectal cancer. I mean, that's so
Sure.
like I said, I anyway, but I certainly agree with raising animals in a better way. I mean, I think that's important, and I like I said, if it works for you, if people are eating more stearic acid and the weight's falling off of them, hell yeah, let them do that. And then, like I'd love to see. That work, and if we could all eat croissants and ribeye steaks, that would be pretty fun. You got to make a stearic acid ice cream or something like that, maybe, or I don't know.
Yeah, maybe perhaps potato chips.
Yeah, who knows? Anyway, all right, man. Well, I'll tell you what, Brad. Just to reiterate, share where people can find you, social media wise.
Sure. So the best place is on Twitter. I'm fire_bottle. My blog is called Fire in a Bottle. It's fireinabottle.net. All of the kind of science is there, as well as my dietary trials and some recipes. Firebrand Meats is the meat site. If you want to buy some low PUFA pork, that's the place to go, firebrandmeats.com. There's also a great discussion group on Reddit, our saturated fat. There's a good discussion of these topics over there. And I'm also Fire in a Bottle on Facebook and Instagram, although I need to do a better job of updating those posts there. But those are pretty much the ways to get a hold of me or follow along.
Hey, Brad, if you are interested, we could probably, if you contact, I don't know, maybe Becky or Amanda, just we can probably put a link to your products on our website for people who want to use that. If you want to, do something like that, we certainly can do that for our members. And I think that's would be a mutual, because we got a lot of meat eaters here that I'm sure would be happy to eat pork and stearic acid butter and that type of stuff. So if you hook up with one of them, maybe, I don't know if Amanda Lee, you can talk to Brad about maybe getting a link onto our affiliate, or Find a Rancher type of site, because we do have a lot of meat companies, just because we want to support you guys. And
sure,
that's awesome. By the way. Anyway, thanks for coming on, man. This has been fun, informative. Like I said, this let's keep pushing the envelope and figuring stuff out. And good luck to you.
Yeah, I love it.
All right, man. Thanks so much.
Yeah, thanks for having me. It's been fun.
All right, we'll see everybody tomorrow. You guys take care. Bye now. Have a good weekend.